Hey everyone, welcome back to week 5 part A. So this is the second topic for week 5 part A. This topic is called exceptions. So an exception is something you've probably seen. It's those red things that come up sometimes in our shell as error messages. So it's an error that occurs while a program is running. So it's a bit different from, syntax errors, right? There's some errors that when you run your code, you get that like pop-up window right away and it highlights part of your code. That's usually some sort of syntax error, meaning you forgot maybe a closing parentheses or, something like that. An exception is slightly different. So exceptions are those things that show up in red in the shell. So those are something that happen while the code is trying to run. So it got past sort of the syntax check, but now it's actually trying to run the code. So when these exceptions occur, as you've seen, your program will stop abruptly, even if it's not, done doing everything you want it to do, and show you that, red error message. So today we are going to talk about how you can handle these exceptions. Obviously, writing good code is one way to handle it, but there are some times where you need more of a sort of direct way to handle them. So if and else potentially can prevent some exceptions, but sometimes you need even something more adaptable. So sometimes you need something even more direct. So we're going to work through an example and we're going to talk about potential exceptions or errors that might come up with this piece of code, and we'll talk about how we can use exceptions and exception handling specifically to make the code just a little bit better. Alright, so here's an example program. So in this program we have one main function and then we call it. In this main function we ask for two integers as input, we divide them, and then we print out a message that just sort of shows the result. So I'm going to go ahead and type up this example into a file here so we can run it a couple times, see what's going on. Alright, so here's that same code again. So again, I run it, it asks for, a number, let's say 10, and then it asks for another number, let's say 2, and then it gives us this, nice little message. 10 divided by 2 is 5.0. So again, it's just essentially asking for two numbers and then showing it the result of their division. So let's think about this code for a little bit, right? What are some potential errors that might happen when I run this code? What is something that someone could type in that could cause issues for us? So one potential thing that might happen, if we go back to our code over here, and I'll go ahead and run it. What if, for example, I say, okay, here's a number, here's another number, 0, right? So what happens when we try to divide by 0? So that's going to give us one of these exceptions, right? So this is one of these errors that you might not think about right away while you're writing this code, right? Take two numbers, divide them, yeah, it mostly works, cool. But you have to sort of think about these sort of edge case scenarios. What if someone types in 0 for this line, right? Then you're going to divide by 0, which isn't good. So again, going back to the first thing that I mentioned about exceptions, sometimes you can just use a simple if and else to sort of handle them. So in this piece of code here, it's the same code as before, except I've added in this if and this else. So this if is basically just checking to see if the second number that you type in is not 0. And then it will only do the division in the print if it's not 0. Otherwise, in the else, it'll print out, this error message, hey, I can't divide by 0, right? So this is one way you can handle that. So if I go ahead and edit my file, so now it has that if else, when I run this, and we'll run it with the same example, 10 and 0, now it gives me a nicer sort of response, right? Instead of this really long red traceback message, it gives me a reasonable response, right? So again, as a programmer, you want to think about potential edge cases like this. Cool. All right, so again, an if-else can sometimes handle stuff like that. That said, as awesome as if and else are, they can't handle everything. So the main focus of this exception talk is to talk about how we can handle exceptions that we might not be able to check with a simple if, a simple else. So again, in the previous example, the same one that we're working with, what would happen, for example, if instead of typing in, the number 10 or the number 40 for 40, what if I typed in the word 40? All right, so what if I go ahead and run this code, run module, and what if I did this? Right? So this also gives us an exception because when I wrote this code here, I'm making the assumption that the user is going to type in an integer, right? They're going to type in an actual number that can be converted to an integer type. Now, technically, 40 is a number, right? When I say, oh, 40, like, we all recognize that as a number, but the code, Python, can't recognize this as a number. It sees this just, simple as characters that you type in, and it doesn't know how to convert this string into an integer. So, with this sort of case, an if-else check won't really work, right? I can't check and see, if the number is 40, F-O-R-T-Y, do all this other stuff, because I'd have to check it for every single number, right? What if the number I type in is 39? What if it's 50? And so on. And it's just, that's not going to work. So let's talk about another way we can handle exceptions that's a bit more adaptable and a bit more direct with this exception stuff. Alright, so this is what we call an exception handler. It's a chunk of code whose purpose is to basically deal with these, slightly, not more difficult, but to deal with these exceptions that we can't fix with a simple if-else. So the way this exception handler works is we use try and except. These are two Python keywords, try and except. And basically you say, hey, try some statements, except some exception, do these other statements. So this is the general form. Pay attention to, again, the words try and except. Note that both the lines that start with try and except end with a colon, and then there are statements indented underneath those two lines. So the way this works is the statements inside of this try, so the statements that are indented right underneath try, the code will try to run them, right? That's sort of the idea behind this word try. The code is going to try to run them. Now, these statements might throw an exception. Let's say they throw an exception called, for example, this one right here, value error, right? So then what I could do in my code is I could say except value error these statements. So the way you want to set up these try and except blocks is you always have the word try, and then the code that you're trying to do is right underneath try, and then you have the word except, and then right after except you use the same exact exception name that came from this red error message, and then underneath the except, that is going to be the code that you basically do if the try fails. So again, code is going to try to run this stuff in try. If a statement inside this try block raises whatever this exception name is, it will stop running the code in the statements under try, but it won't throw an error message. Instead, it will just sort of jump down into this except piece. So it's pretty cool, actually. It's basically a way to sort of directly avoid potential exceptions and to handle them, which is why it's called an exception handler, right? Something of note about this try and except is in this sort of setup where you have try, except, exception name, that exception name needs to match the exact same type of exception that is thrown in the statements that are under the try. So for example, if there's another exception that happens, a different type of exception that happens, and we don't have it listed here under this except part, it's still going to error like normal. So you have to sort of pay attention to what possible exceptions might be happening for this code to work, but it's still pretty useful. Alright, so let's go back to this example, right? This is what we had before, and we had, this if and else, we threw that in, we made it a lot better, but we still ran into this issue where if I type in, a number 40 like this typed out, we get this exception. And now the name of the exception that happens is right here, is this thing that says value error. So that's the name of this exception here. So if we go ahead and take this code and edit it just a little bit, so we're still getting the input, we still have the if and the else. So the only pieces of code that we're going to add here is basically this try and this except. So let's go ahead and do that, and I'll do it with you. So we're basically going to put this whole thing under the try. Again, pay close attention to all those indents. Anything that's part of this try has to be indented. So if it was already indented, that means, for example, here, there's going to be a couple of indents there. And then lined up with the try, we'll put except, and right here, for the exception name, we're going to use this exact same exception that came up right here. So you can even copy and paste that, put it right there, and you see how it changed to this purple color. So if this changes to the purple color, that means you're typing in an exception that Python understands. It works, it makes sense. So the code is going to try to do this. If this code raises this specific exception, then I'm going to have it print this message. So again, the way this works, I'll run the code, I'll type in numbers. If either of those two numbers raise this specific exception right here, this specific error, it will stop trying to do all this in the try, and it'll just skip to this sort of except. So it's going to try this. If it doesn't work because of this error, it will just print this instead. So let's go ahead and run it. And just to show that that divide by zero is still, check is still working, let's just do this demo really quick. Cool, we're still getting this cannot divide by zero message. Let's go ahead and run it again. So let's try it with, that other issue we were talking about. What if I type in a number like this? Before we got this sort of long red error message that is kind of annoying to read, right? Now I get this nice message. And again, the way this worked is because of this really nifty try and except. It's tried to do all this. If any of this raises this exception, it will just do this instead without showing us this red message. So exception handling is pretty a powerful tool. It's very useful to sort of deal with edge cases like this. I'd say it's very common when you're dealing with a lot of user input because, if you're allowing other people to type in input into your program, they could type in whatever they want, right? And maybe it's not what you intended. So exception handling is super useful. In Python, we use try and except. A couple things that I do want to point out in this previous example, the exception that we were dealing with was a value error. All possible exceptions that you could potentially have come up are listed in the Python docs. There is a link on Canvas to the Python docs with all the exceptions in it. That said, I am not going to expect you to memorize all the different exceptions. That is not what I want you to get out of this. What I want you to get out of this is if you're writing code and you see this exception like this, I want you to then be able to go into your code and basically write this try and except by saying, okay, here's the exception name, let me just copy and paste it and put it here in the except. So again, for this class, you do not need to memorize all the different exception types and like why they happen or anything like that, but you should be able to write a try and except once you see what the error message is, and you should just also understand how they work, right? You should understand that the code that's part of the try block, it tries to go. If it raises, that specific exception, you'll jump down into the except block instead. If there's no exception, it will just run the code in the try as it normally does. So if you have any questions about this, please do let me know. Otherwise, I will talk to you all next week.